Hello and welcome to another episode of FireDEV, a fireside chat with developers. Today I have Etay Meiri here with me, and he is an ex-Cisco and current Intel engineer. So welcome Etay, and do you want to tell us a little bit about yourself?
Hi, yeah, sure. Yeah, so my name is Etay Meiri. I'm a software engineer at Intel. I've been working there for almost 17 years, and I have three kids. And in my spare time, I maintain an OpenGL tutorials website at ogldev.org. And recently, in the past year and a half, also a YouTube channel by the same name where I continue my activities of creating OpenGL and also planning some game development in the future, tutorials in video format.
Okay, so what was it like working at Cisco, and what did you specifically do there?
Okay, so about 20 years ago, I worked at two startup companies, which was a very interesting experience being a young developer. And so the first one was hit by the dot-com bubble, if you remember, and also there was the September 11 attacks at the time, and it all came down together with the market crashing, and then the first startup was shut down, and very quickly I moved to another company, also a startup, which was purchased by Cisco um, after about a couple of years of activities. And so it was very interesting because I was still not very experienced, just a few years working in the industry, and moving to a big company from a very small company. But I think the transition itself was okay because the way that Cisco works is that they are basically a company that was built by purchasing and integrating smaller companies, a lot of startups. Um, so they know how to do this well. They give you the feeling that you continue working inside your own team, and you don't need to change much of your culture or all the processes. But the main problem there was that it required us to do a longer commute. Okay, so if previously it took me 10, 15 minutes to get to work because the company was located in the same city, I now had to commute for 1 hour. And I know that in many places in the world, especially in America, they would probably laugh right now because it's very common for many people to do an hour or more commute. But for us, uh, I mean, I guess we're spoiled in a way. Um, uh, Here, many people are able. I mean, depending on where you live, of course, but at least I live in Haifa, Israel, and so we have a large center of high tech downtown, and it's very easy to get to. Especially back then, 20 years ago, the traffic was less and all that. Um, so it was very difficult for me to maintain this commute for a long time. So after about a year and a half, I decided that I need to shorten it in a way, and then I moved to Intel. Um, but in terms of working at Cisco, we continue working on the same product. Only now that it was a larger scale, so it was integrated into a bigger product by Cisco. Um, it was the product itself was enabled um, the idea that you can access files on your Windows server that are located remotely and get the impression that it is hosted locally in your own office. Okay, so it's a lot of tricks and optimizations on if you know the CIFS protocol or the SMB, what Samba, the open source file sharing for Windows, allowing you to connect from Linux for Linux to Windows. So it was a lot of work on this protocol, making it making it more optimized so that you can do remote work and yeah, having the impression that it is done locally.
Okay. And so that company that got bought by Cisco, was it Actona?
Actona, yeah, Actona.
And so, when companies get bought by larger companies, I don't know how it is at Cisco, so this is why I'm going to ask. Some companies are notorious for buying them and then shelving their products, and then like their company basically just getting shut down. Was that the case for Actana at all? And did you have to move on to a new project, or was that the case for other, companies that Cisco bought that you saw when you was there?
Okay, so for us it was very different. I mean, as I said, we continued working on the same product. Only now it was integrated into their framework. Okay, so I don't remember all the specific details. I think the acquisition took place in August 2004. And so initially, we simply continued working on the same product. And what Cisco tried to do is to have their marketing team, their basically their business unit, pick up where we were and just make it a larger scale. So offer it to more companies because products like that, people don't appreciate it, but oftentimes technological people, they have great ideas for various products that can be sold to companies, to big corporations, whether it is security or networking or whatever. Not like an app or social media stuff like that, but to big corporations, and then they don't appreciate what it takes to actually make a sale. And then I remember that the people told us that it can take 10 months to a year or more than that, just for all the engagement and for the company to do their testing until they decide that they're gonna buy your product and integrate it into their processes. Can take a long time, and it's very challenging for all those small companies that are trying to break out and start doing sales, get the money flowing in. So Cisco enabled us to reach larger markets, to engage with more customers, and eventually they started integrating the product into their larger portfolio of products, because they were doing similar stuff. So for example, if we were working on the Windows file sharing protocol, they were doing similar stuff for HTTP. Okay, so they were building various caching solutions. So if your company is doing a lot of, every company is doing a lot of web access, and in many cases, because of the business needs, many people are accessing the same resources online. So a system that can cache, proxy and cache these websites can often provide increased performance for the local user in the office. So they were doing similar stuff in HTTP, and they just wanted to provide the customer with more capabilities. So not only HTTP, but also Windows, centralized file sharing. And I think that was at the time that I quit, so I was not really involved with that so much. But I remember that I was still working on simply the same features that I started working on previously. So it's not that big of a change, at least for us. But for other companies, um, well, I don't really know much. I remember that while we were there, they acquired more companies and they integrated them as well. I mean, into the facility and everything. But we didn't. We were not very much in touch with the other business units. So that was also the thing, that you were still only with the people that you work with, And also, when you hired people, you were the one that was responsible for doing all the interviews, and then you would present the new hires during the interview process your product, and then they would come and they start working on that product. Okay, so you're not doing interviews for other business units for products that you are not familiar with. So it was very, very self-contained in that regard.
Okay. And with startups traditionally, actually, for first of all, how when did that startup, begin, Actona?
So I joined early 2000, was it, or during the yeah, I think it was April 2000, and I think they started about a year or a couple of years earlier, and they also did a change of strategy. I think they also started with something else, more about HTTP and web caching. I think they had a web caching solution because the guys that started this company, and three people by the name Israel. Okay, so they initially called their company Triple I Networks because you know their initials were all the same. So and they started with web caching because they had experience with that domain. One was a professor and was working on distributed systems. Another one came from a different company that was also involved with networking. So they had a lot of networking experience, and they wanted to optimize the web. So I think they started with the web caching, and then sorry, they moved from they felt that it was not working very well, and they felt that there was an opportunity with SMB or CIFS, the Windows protocol, and then decided to move to file sharing. And they had some prototype for that. And when I started working there, it was exactly the time when we kind of moved from a prototype to an actual product. So it was a very good opportunity to um, make have an effect on a new product. It's not like when you oftentimes when people start working in companies, they get into very established product and they start working on some small feature, and often it's very difficult to really understand the entire system. But when you start at the right moment, if you get the opportunity to really build the system from scratch, then you're in a good position to continue and promote yourself.
Okay, and with startups traditionally, especially like technology startups, when you join relatively early, they give stuff like, shares and stuff like that. And when they get bought out by a big company, there's obviously usually a payout, and sometimes the employees that were there pretty early on, get something. So did you and the rest of the team get anything extra as a result of the Cisco buyout, other than, your regular salary?
Yeah, so we got. I mean, honestly, I think from retrospect, if you want to get rich by joining a startup, then you really need to be in a very high level position inside the company. So, like director of development or executive vice president of R&D or whatever, because otherwise, even if the company, I mean, it's obviously very different. It's if the company is 100 people, and I mean, we were purchased for $100 million, which sounds a lot, but there are many people in line taking their share before you. So there are investors and the
Yeah.
angels and all that stuff and founders, and then when you get to the head of the line, it's like Oliver Twist. Can I have some more, sir? So
Yeah.
um,
There's
so
just
it's
crumbs
not
left.
it's yeah, the Scrum. So yeah, I mean we got shares, but I mean if you compare it to like a company like Intel, Microsoft, all the big companies that are giving you bonus salaries. So I don't know, depending on 2, 3 salaries a year, and then you go to a startup, so you just get your salary and you don't get any bonus at the end of the year. And then after a few years, the company is purchased, and then you get some big amount of money. But it's still, when you compare it to working in another company, to what you were able to make at the same time, just with standard bonuses, I don't know. So again, it depends on whether it's $100 million or $1 billion. I mean, but whenever I look at these at the numbers, when it's in the press, and when it's at that order of a few tens of millions or even 100 million, I know that people will probably not make a lot of money from it unless they are part of the senior management team or
Mhm.
very close to that. Then yeah,
Or the
they can make.
founders, essentially.
Yeah, of course, the founders usually make a very nice uh, amount of money. Yeah,
Yeah. Okay, but obviously then they took the risk, and obviously they would have,
yeah,
with a lot of startups, they would have been doing the work when not much money, if any money, was coming in. So yeah, I think that is fair enough that you know they're the ones first in line. Okay,
yeah,
so why did you leave Cisco and like ultimately Actona as well?
yeah. So it mostly because of the commute. I found it to
Okay.
be very difficult. Not just the distance, but also the traffic. The way that specifically my commute was about the last quarter of the distance was just sitting in traffic and waiting to get there on the last few kilometers of the way, just to get into the office. It was very tiring. And also at night, you leave the office at 6 or 7 p.m., and then you have another hour to drive to get home. So it was just not. I was just not happy with that. So I told myself I have to find something which is closer. And
Okay.
Has I mean, Intel's one of the largest R&D office in Israel for Intel is in Haifa. I mean, today, back then, certainly. Today they have other locations in Jerusalem and other places, but I think that Haifa is still the largest location. So it was it made sense.
Okay, that's good. And what sort of technologies at Cisco and Actona did you use? Like what languages, what technologies, that sort of stuff.
Yeah, so the product itself was developed in Java, which may surprise some people, especially then, 20 years ago.
I mean, it
But
did. I was expecting
yeah,
C to say C or something like that.
yeah, this is what you would expect. But
Mhm.
I don't know. It's just a cultural thing, because the major powers, the major technological powers in the company, they selected Java, and they made some experiments, and came to the conclusion that Java was all right. So the advantages outweigh the disadvantages, and this is what we use. So we used, I think, IntelliJ IDEA for the development, and everything was done in Java. Um, Also, I think the tools, there was some. I mean, some people were doing web development, but for me it was mostly because I was in the core team on the actual server. Then it was all Java.
Okay.
Um,
And so, what made you join a startup? Because the company before, which I think was Camelot, and then
yeah.
Actana, both startups. What made you join a startup instead of going for a more traditional, bigger company from the start?
Yeah, so if I remember correctly, I just went to a few interviews, and Camelot at the time was very attractive. It was it's a high profile company, and it just seemed cool, and everything there ticked to what I was interested at the time, which was kernel development, and it just seemed like the best option. And then when the company shut down, and it was like a very long and agonizing process, because initially there were like three waves of layoffs until the company was finally shut down, and I survived all of these layoffs. And there was kind of like one of the guys who closed the door, shut down the lighting and everything, and closed the door. So, and then when that and when I was out of there, I just looked around, and I went to a couple of interviews, and I had I just had an excellent interview with Actona. And I think it's often like that, when you go to a place, and you have, sometimes you have an excellent interview just because you connect well with the people on the interview. And this is what I felt, that the interview went very well, and the interviewers were very nice, and a great chemistry. And at the same day, they called me up, and they said that they want to give me a job proposal, because I went there and I did a few interviews in a row. So they just moved me from one person to the next. I did like 3 or 4 interviews, all the way up to the director of development. And then in that evening, he called me up and said, "Look, we want to give you a job proposal." And then, just made sense to start working there. So it's not like not like I told myself I want to work specifically in a startup. It was just the opportunity presented itself.
Okay, that is fair enough. And what was it, like working at Intel? And I mean, no, what is it like for working at Intel? Because, you've been there for about 17 years, you said. And what do
Yeah,
you do there currently? And how has that changed over that time period?
yeah. So that changed a lot. I mean, Intel is like that, where in some companies, um, when they have product that they are selling to companies, to customers, and they need to maintain these products over the years. So sometimes you would go there and you find yourself just maintaining a piece of software where everyone is happy. The customer is happy. The customer keeps paying for, bug fixing, few features here and there, but there is not a lot of changes. And the companies is happy because they have a paying customer, so they just need to satisfy to this customer, and they have a team that does that. But there are no like major changes, and it's the same code, possibly some old technology. But the way that it works for Intel is that everything changes all the time. So in some cases, I know people in some teams that they keep developing the same technology, but they do major changes in it over the years. So it's not like the same piece of code, or it's not like stagnating or anything. They keep making breakthroughs. But in many other cases, you work on a project, and that project does what it's supposed to do, and then they decide that they have higher priorities, and they will simply start a new project, and they will move the team to another to this new technology or whatever. And for some people, it may be, some people find themselves in kind of new environment, and they may not like it. But for me, it was always most of the time was okay. So I moved through several technologies and several projects. I mean, when I started, it was all about virtualization technology. Okay, so this was at the end of 2005. I remember it's December 2005, and they, at the time, VT, virtual technology in the hardware, was a major thing, right? Because there was VMware, and there were a few other solutions that were using software solution to do virtualization of one operating system on another. And Intel saw the opportunity to improve the performance and the security of virtualization. So they started adding features to the hardware to do everything faster and more secure. And this was called VT, virtualization technology. And we were working on a product for security, kind of like a demonstration product, but Intel also tried to sell it to companies. And eventually, due to various problems, this it didn't pan out, and the project was shut down. And I found myself kind of like without a project. So, and then I heard about graphics, and then this was actually my first interaction with, or my first encounter with graphics. They had another team there in the same building, different level, and just went over there with a couple of guys. We talked to them, and we decided it was very cool to work on graphics. And me and those guys, we just moved there together. And this team was doing um, kind of a product that or software that takes an offloading solution that takes the vertex processing. So everyone who's working on graphics knows that there's vertex processing and there's pixel processing. Back then, today with the pipeline, the graphics pipeline is more complex, but usually everything is done in the hardware. Vertex, all in the entire pipeline, both the vertex and the pixel shading. But at the time, Intel was not very good at graphics, so they wanted to help the GPU by offloading some of the stuff to specifically the vertex shading to the CPU. And this team was doing just that, using the CPU, the latest technologies at the time, which was like SSC4, I think, or one of the generation. They started with MMX, and then they moved to SSC1, 2, 4, and everything. Today we have AVX. And so the idea was to offload some of the work from the GPU to the CPU in order to increase the overall performance. And that was the job of the team. So I thought the product was very cool. The idea was very cool. We had to work with a lot of games, which was also very cool. To take a game to make sure that everything is working correctly, to do a lot of benchmarking. And so I moved to this team, and I was there for many years. I was there, but again, we moved from one product to the next, because eventually the GPU was able to pick up the momentum and improve to the point where the CPU was not required. You could do everything on the GPU. And then we moved to another technology and another product. And eventually, about 5 years ago, Intel decided to switch priorities, to lower the priorities of graphics, at least in our business group. And then I moved to a project about a deep learning project. And this is what I'm actually working today. Also, it's not the same product today. What I'm working on is basically helping the effort to be part of the effort to improve the performance of future Intel technology for deep learning applications. Okay, so if you look at the market today, deep learning is a big thing. A lot of stuff is done using deep learning, machine learning. A lot of very difficult problems are solved using deep learning technology, and everybody is trying to get their hands into it. I mean, from a hardware perspective, everybody is trying to to provide some sort of a solution. So it can be on the GPU, like NVIDIA, AMD, sometimes very specialized accelerators that are doing it with a custom-made CPU, and very often Intel is buying out these companies in order to, because no one knows what will work best. But we are focusing on the servers. So there are new features that are planned for future platforms, future CPUs, and we are helping the people that are architecting these features in order to improve the performance. So when that chip hits the market, it will do what it's supposed to do in terms of performance. It will deliver the expected performance.
Okay,
Um,
you mentioned that you worked on some stuff where you are optimizing games because Intel is, not a games company, though they, make a
mhm.
lot of, technologies that are important to the gaming industry. So was that,
Yeah.
bigger companies essentially saying we've got this, new game we're working on, maybe with some new hardware integration or technologies with that engine. Can you have a look at optimizing it, or how did that work, and what sort of games did you do the optimization on?
Yeah. So what Intel is doing is that they are investing a lot in having people over in major companies. So they have, I mean, in the case of strategic engagements like Microsoft and Google, then they would have an entire team of I don't know how many people just to work with these companies and to make sure, like in the case of Microsoft, to make sure that new versions of Windows are working best on Intel technology, and I guess the other companies are doing something very similar. But in the case of smaller companies like game development, so many, I don't know, I mean, many of the major companies in that field, then Intel kind of has an account with them. So they have one person, two-person there to help these people integrate the technology that Intel provides, because it's very difficult. When you're a hardware company and you create a new technology, like new instructions, which is very very low level from the point of view of developers. Developers today are working with the Unity, Unreal, or any other um, engine, and you've just put out a new instructions that can make some part of a game work very fast. So how do you get that over to really impacting the products that are coming out? So one of the ways to handle that will be to send a person there which is an expert sorry, on that technology, and then help the companies that are willing to do it, help them actually integrate the new instructions or new libraries or whatever into their products. So this is called enabling, or you can call it post enabling, because these companies will mostly work with existing silicon. Sometimes, in some cases, maybe under some conditions, NDA, uh, they will get access to silicon before it is released to the market. Just to test it and provide feedback and to benchmark and everything. What I'm doing is actually called pre-enabling, because we are working on silicon 5, 6, 7 years before it is released, uh, which is one of the major challenges in this work. And so this is the kind of engagement that Intel has. So we are not working directly with the companies, but we knew people who do work with them, and whenever there was an opportunity, um, it's very difficult to make the flow of information work inside a big company. It's always always a major challenge. We have certain type of people that are working with companies, and they are getting a lot of feedback. They know a lot of what is happening right now, what are the problems that the customers are facing, and then you want to get that information all the way to the people who are working on the architecture of a future CPU. And it's a big gap how to get the feedback out. It's like I don't know, like a big army, and you want to get a certain type of intelligence from one corner to a very distant corner, and it's a challenge. It's always a challenge like that. I see it even today in a different project in the deep learning. They're always trying to get people working as closely as possible to bring down the walls between organizations so that people can engage and be more efficient. And so we were not working directly um, with the companies because we were kind of like part of the driver team. Our solution was integrated into the DirectX driver, so it was just part of Windows, and which it worked seamlessly under the fit of the game. And at the time, we were working on all the major games. Like I remember, we had a full stack of CD-ROMs or DVD at the time, and games like Company of Heroes. I remember working a lot on DMC4. That was a Devil May Cry, and I don't know, Brink. A lot of titles, and also benchmarks. So like 3D Mark and various other asterisk mark kind of benchmarks that were doing graphic benchmarking. We were also working on these as well.
Okay, so you was optimizing those games and those benchmarks effectively, and working with their core development team to make sure that they was able to use the Intel technology as efficiently as possible. Is that correct? Is that basically the interaction?
Okay, so this actually optimizing the game was the job of an engineer, which was sometimes on site with the company, with the development studio, and sometimes remotely. But for us, we were more on the driver side. So we were not exactly optimizing the game. We were optimizing the driver, or we were analyzing the driver to find bottlenecks, and then try to introduce. Since we were doing this offloading solution, we focused on optimizing the CPU part of vertex processing.
Okay, so it's basically like how a new game comes out, and then let's say Nvidia releases a new set of drivers, and they're optimized for that new, game. Is that effectively like the relationship?
Yeah, I mean, kind of, yeah. You you
Okay.
you find that the bottlenecks that the game experiences, and if it's depending on where exactly is the problem. If it's in the GPU, then the driver team will work on that if the game doesn't hit the expected frames per second. But if it's more on vertex processing, that this was part of our solution.
Okay, and for big games, and no, I mean just big applications in general, was you getting an early version of those products before they launched, or was it as soon as it launched, Intel, purchased a bunch of copies and then you tested it to see if it worked okay or not?
Yeah, so I think we mostly worked on the existing released versions. At least the team was not at the position to get early access. I think perhaps to benchmarks. Maybe I don't remember if we were able to get early version of major benchmarks. But I think in games we just bought the games themselves from the store, and we just had them over there on a shelf and then worked with them. We didn't have access to an early version of a game.
Okay. And so far, it seems to be that you've been doing low level stuff even when you was in the startups. What made you do low level stuff? Was it just something you fell into, or did you have a passion, for low level when you were a kid or when you did your degree?
Yeah, so I was always interested in that. I mean, I remember when I was a student, and I worked as in some ISP, an internet service provider. I was working on customer support, technical support. And then I heard, this is where I heard the word Linux for the first time, because I didn't hear about it anywhere else. This was in 97, 98. And then I remember buying the CD-ROMs, waiting for a month to get them, and trying to install Linux without any help, and just bashing my head against the wall to get the system up and running. But I immediately saw that it was much more advanced. I mean, I don't know if advanced the correct word, but it enabled you to do much more than Windows 95 at the time that everyone was using. So it was much cooler. And then I started exploring C++ as a student, eventually getting a book about Unix project, and just started doing various projects there that were suggested that can help you get up to speed with this kind of development. So a lot of stuff about processes and sockets and multi-threading, and just interested me more than, I don't know, web development. To this day, I mean, I don't know much about web development, so I was always working low level. And in these companies, I mean, Camelot developed a security product, so obviously it was very low level. Um, and for actually very similar, in some respects, similar to Actona. Their security product was working on mostly on Windows, on low level file handling. And then when I switched to Actona, some of that um, some of this information, what I learned there, was relevant to the other company as well, because of low level file handling stuff. And so again, file sharing, even though it was all a user space product, it was very low level. And then virtualization technology, again, you work under the operating system, then drivers. Um, and today, a lot of assembly level optimizations. So it was always like that.
Okay, and so you've done software, development on software. You've done development on hardware, especially low level stuff. What would you say the differences and the similarities are, and which one do you prefer working on?
Yeah, so I'm not doing. I mean, I'm not doing hardware development. I'm always on software. It's just that Intel calls it hardware software co-development, where you develop the hardware at the same time that you develop the software that is supposed to run on it. So there are hardware people, architects, micro architects that design the hardware itself, all the elements of the hardware, and but we are always on the software side. So hardware engineers often see the world from a very low level position. They have difficulty understanding the needs of the software development that will later use their creation. So we're kind of trying to help them there, and provide the software that will run on the future hardware before the hardware is even produced. So it's a lot of work on simulation and stuff. Um, so it's always software for me. It's not really like developing hardware. Whenever I need to engage, I mean, to understand what is going on with the hardware, I go to the architects and get their help on it, because you really need to be an expert to understand why a piece of software is working slowly, You get a trace, and then you go to the architects, and then you sit with them, try to understand why it is working so slow, whatever.
Okay, and you mentioned before that you sometimes worked on silicon, hardware stuff. Obviously, even from a software perspective, 5, 6, 7 years before launch. So, what's that
Yeah,
process like? Because let's say if you're working on the, like a CPU, like an Intel CPU, for example, if that's a half a decade plus before it's due to come out, let's say the GPU that would, the GPUs that would probably be paired with it are not out yet. The motherboards, traditionally are not out yet. Like it might even be a different RAM standard potentially that is just not, traditionally out yet. As is the operating system, because it could be two, new versions of an OS in that,
yeah.
in that time. So what's that like, and what are the restrictions around developing it so early? Obviously, you have to. You can't just develop it, a week beforehand. But what's the restrictions with that?
Yeah, so the way that this works is that, this is one of the major challenges that, I don't know how long it takes to do that in other companies, but for Intel, it's several years, 5, 6, sometimes more years to develop a hardware. You start by kind of the first stage is just trying to understand what this future CPU will include in terms of features, and what is the target in terms of the frequency, what type of memory will this work with, and the, often this is where we do most of our work. And then there's kind of like a pipeline where once you finalize what you want to put in the CPU, you start to design the architecture and the micro architecture, which is sometimes there's a boundary between them, which is sometimes difficult to understand exactly. At least for me, because I'm not part of this effort, so I can't really tell you what is architecture and what is not. And then once the architecture is complete, they move to design, where they design the actual, all the gates and everything, the description of the actual hardware, and then this goes to manufacturing, and then the first CPU comes back, goes to the lab. They try to bring it up. They have some bugs, and then it goes back and forth um, to manufacturing. And this is where you try to by doing a lot of. All this is done by software, right? Because you don't have a hardware, so you need to do everything in software. So you work a lot with simulations, and there are various simulations, various types of simulators. Some of them will do functional checks. So let's say that you introduce a new instruction, then you can put it in a simulator, and a simulator is not like an emulator. Okay, so many people are familiar with emulators, where you take like a Z80 code from the Spectrum 48K that I used to have 40 years ago, and you can run it today on on the latest CPU, on Windows, Linux, whatever, and then just play the game. Because what the emulator is doing is just translating the instructions into something which they are supposed to do, and providing a virtual environment for the code to function correctly, as if it is the same machine. But they are not trying to simulate the actual instruction in the old CPU. They're just trying, if you have like an add instruction, and it's different from the add instruction on an Intel CPU, they'll just translate the add from the old CPU to the new CPU, because the result will be the same. But what a simulator does is that it simulates the actual hardware, and it is working, which is why it's working so slowly. But it provides you um, the actual behavior of the silicon just in software. So everything that is going on in every cycle inside the hardware is simulated in software. So you need to bring up this simulator sorry, as fast as possible in order to start doing useful work for all the features that you are trying to develop. And so this is like a function simulator, and you can also um, use a performance simulator. So you will take a piece of code that is taking whatever number of cycles to run today on an existing hardware, and you want to know how fast it will work on a future CPU, and to bring in not just the changes in the architecture, but also the changes in frequency. Okay, so if today it's working, if you have a CPU today which is clocking at 2 gigahertz and it will be 2.5 or 3 in the future, and also changes in the architecture at the same time, you don't really know whether an existing code will run faster. Maybe it will run slower. Who knows? Because maybe you've made some change. You cannot test all the software in the world, so you may have introduced some changes that are improving the performance of one piece of software, and then it hurts the performance of another piece of software. Okay, so we have you have a simulator that can tell you the number of cycles that this piece of code will run on, given a specific process CPU generation, and also frequency. And yeah, so this is the kind of work that we're doing. It's all I
Okay.
mean, writing. Yeah.
So, what was the interview process like for Intel? A big company like that, doing the sort of stuff that you're doing. What was it like?
So I think that the interview process is very simple. Um, I mean, if I compare it to interviews that I've done in the past with other companies, um, for us, and I think for many departments, um, usually you will be interviewed by the people that you're going to work with. So it depends. It depends. I mean, in the past, I was working on inside as part of a larger team, or larger department. 150 people. So, and I was interviewing for the entire department. So sometimes the person being interviewed, the position was for my project, and sometimes it was for other projects. And I was able to explain what the department is doing, because the it's not like there one guy doing web development and another one doing low level. Most of the teams were doing low level stuff, so it was easy to explain what is the role of the department and what it contributes. And today we are in a smaller team, so everyone who's being interviewed is for our team. And you have two interviews of about 2 hours, and basically you just need to describe your experience. If you've worked with other companies, then we would ask you questions about what was your role there, and what challenges you had to solve, and just get an understanding of how that person performed. I mean, it's always a big challenge is in you need to get an idea of how well this person is as an engineer, and how fun it would be to work with. And so you have like two interviews. First interview is people like me, software engineers or hardware engineer, whatever. And then the second interview is with team leaders or more senior engineers. And if you pass these two interviews, then you are invited to get a job proposal. And that's it. There are no interviews like in HR or whatever. Just those two interviews. And that's it. So I think it's very simple.
Okay. And so, what's your preferred development setup? At work and at home, and just in general, because obviously, every developer has their preferred setup. The hardware, the software. So, what's your preferred setup and why? And how has it changed over the years?
Okay, so in the past few years, I mean, all of our development is done on Linux and using C++, and every person has their own preferred development environment. So I'm using, depends on what I'm on the specific part of the system that I'm working on. Sometimes I'm using C Lion, and sometimes I'm using Emacs. And since this is Linux, there's always a lot of working with VI, because whenever you need to bring up some file, some configuration, or even a piece of code that you want to just quickly fix, then you'd use Vim. And some people prefer to work only on C Lion. So C Lion is very popular in my team, but it's changes from one team to the next. And at home, I'm also using Linux, but I'm only using Emacs. So all my graphics works graphics work is done on Emacs, and also again also always using Vim from the terminal to do quick editing of configuration or anything else. So it's very
Okay.
simple.
Okay, so that leads me on to my next question. You've kind of answered it, but I was gonna, dive into it a bit more. Vim or Emacs, and why?
So I mean, I'm not biased to any of them, and I'm always interested in watching videos that help you improve your development workflow. I always feel that my development workflow is not optimized enough, that there's a lot more that I can do in whatever environment to improve my working speed. And I was trying for a time to work exclusively on Vim, but I was not able to get to the speed that I can see other people are working at. I mean, if you see some YouTube videos of people speed editing on Vim, they work much faster than me, and I was not able. So when my experience was, my personal experience was that I can type and edit faster using Emacs. So eventually, I gave up on Vim as the major development environment and switched to Emacs. But whenever I need to do very quick editing, then I would fire up Vim from the command line. And also, I was able to get all the plugins working better on Emacs. So I'm a big fan of Swiper and Helm. They are excellent packages on Emacs that I was able to get up and running. It often happens that I read some tutorial on how to implement some, or how to get some plugin up and running, and it ends up not working on your environment, and you spend a lot of time trying to get this to work, and eventually just give up and then work with whatever you have. So in terms of the plugins that I was able to get to work, I'm working with Swiper, Helm, and a bunch of other stuff, and I really like being able to jump around using Swiper, also Ace Jump, stuff like that. And this is what I use on Emacs, and on Vim, I was just not able to get a good replacement for that.
Okay, I mean
Maybe
that's
partially.
that's fair enough. And why, Linux over using something else like Windows or Mac for your preferred OS? And has that always been the case?
Yeah, I mean, personally at home, The last versions that I used was of Windows was Windows 95. I think after switching to Linux, I never looked back. It always felt more natural for me to work in a Unix environment, and this is what I taught myself to do using books and everything. I always invested in that direction. And I don't know, just for me it was always simpler, just understanding how to build the kernel and everything. And it always seemed to me like I understand more about the system than people who are working on Windows. And I don't know, I just like it. And at work they just use Linux all over, so it's a no-brainer. Let me tell
Okay.
you something else about came to my mind about Emacs and Vim. It's sometimes what makes a difference is that if you have someone who is an expert on one of the tools, and if you have someone to learn from. But for us, I mean, for me, uh, I never had someone who is an expert on either one to help me improve on that specific tool. So I always had to do it myself, and people tend to to get away from these tools. I mean, young people today definitely prefer to use whatever GUI environment. So this is why C-Line is so popular in my team and other places as well, or other, in case of Windows, you would use Visual Studio or Visual Studio Code. I mean, it's a no-brainer. Not many people use Vim or Emacs on Windows. I mean, probably the percentage of people using such tools is much lower on Windows than it is on Linux. So it's
Yeah, I can see
difficult
that.
to find someone who can just fix your problems right off the bat. And sometimes it's the make or break of working with such a tool.
Okay. And what's your preferred Linux distro?
So for many years I was working with Ubuntu, and in the past few months I've switched to Linux Mint. Before that I also used Fedora for a few years. I mean, I started with Slackware. The Slackware Linux was the first Linux distribution that I've used. Um, I remember buying the CD-ROM from a place called cdrom.com. I think it no longer exists. Something called the Walnut Creek or something like that. They were selling. They would send you like a very nice package of 4 CD-ROMs or DVD. I don't remember, of the entire distribution, and this was Slackware. And from Slackware, I moved, I think, to Fedora. I also tried FreeBSD for a few months. It was a very long time ago, and then I eventually moved back to Linux, and then Ubuntu, and now Linux Mint. But Linux Mint is also based on Ubuntu, so it's not that big a deal.
Okay.
Uh,
And what do you think of stuff like VS Code that has become really, really popular over the last few years? And have you checked it out yourself?
I checked it. Yeah. Um, I don't know. It didn't click for me. Um, Maybe I'll try it again in the future. Um, I'm really comfortable with my Emacs environment. I would like to improve it. I mean, if I can find the time or get the help to maybe learn a bit of Lisp, Emacs Lisp. Um, I think that when you are an expert on this kind of environment, then you can really be very efficient in terms of tailoring your environment to the specific project that you're working on. So I don't feel that I'm there yet. I think that I have a lot more to improve. It's often a challenge because you need to do your actual work, but you want to improve your environment. So when exactly do you find the time to improve your environment that will make you work more efficiently? You know, so I can't say much about Visual Studio Code. I know it's a bit. I know it's popular. Specifically in my team, no one is using it. So
Okay. It
it's
might be
not like
more
I can
popular
actually.
on Windows, perhaps, compared to,
Yeah,
let's say, Linux.
yeah. So on Windows, I simply use Visual Studio Community Edition.
Hmm.
So I try to make my tutorials work both on Windows and Linux. And on Windows, I'm using the latest version of the version of Visual Studio. So I don't know. I mean, Visual Studio Code is more lightweight, right?
It is, yes.
So
It's a lot more
yeah,
plugin friendly. I think that's what. Uh, I mean, in my head, I might be wrong. I see it kind of like a modern Vim or Emacs, where it's not as bloated as something like Visual Studio or Xcode, but it's a lot more flexible. There's a lot of plugins. You can sort of tailor it to
yeah.
your needs. So it's kind of like the
Hmm.
Windows equivalent, even though obviously I think Vim and Emacs is on Windows, but it's like the Windows equivalent for those pieces of software. So it's almost like people that never really worked on Linux and never because Visual Studio as an IDE is very good in my opinion. So I think a lot of the time they just use that, or maybe IntelliJ or something, or maybe Android Studio if you're doing Android development. But now
Hmm.
VS Code has come along. You can do all those little different things in one, including web development as well, and especially
Yeah.
considering software like Brackets from Adobe is no longer supported. So I think it's like a you know Linux Vim Emacs experience, but on Windows. I mean, that's my take on it. So for VS Code,
Hmm. Yeah. That makes sense. Yeah. So I don't do a lot of different. I mean, if it wasn't for my website, I wouldn't do any. That's mainly the only reason why I have a Windows partition on one of my machines, just to be able to run Visual Studio and to test the code there.
yeah.
And so, I mean, in the past, when we were working on DirectX drivers, then obviously it was all Windows work, and Visual Studio was the simply the only environment that everyone was using. And I remember it was always very good in terms of quickly switching from editing to debugging with a single click, putting breakpoints everywhere. Um, I mean, it's working for me faster than I can do it on Emacs. It's for Emacs, it's always some kind of configuration, everything. So this is what Visual Studio is good at. I think for debugging, it's very good, and also the IntelliSense and everything is working well. So for C++ development, that's the only thing that I ever try to use it for. Just C++. I mean, we are using Python as well as a tool to. I mean, in order to develop various supporting tools. So, but I never try to develop on Python. Develop Python on Visual Studio. I think it can be. It is supported, I think, but I never tried that.
Okay. And so briefly mentioned that you run a website called ogldev.org, and that's actually the
Yeah.
first time I came across your work. Before I knew that you worked at Cisco and currently at Intel. I knew you from that. What made you start that website, which is obviously OpenGL related, compared to doing something else? Because you've obviously you have your job, but obviously this is like your side project. Whether or not you want to make this into a full-time thing, we can talk about that. But you've done a lot of stuff over the years. What made you do a website on OpenGL versus the other low-level technology stuff that you've worked on, instead of creating tutorials for that instead?
Yeah. So for me, whenever I start working on a new technology or a new project, It's very the way that I learn or understand how everything is working is by doing stuff from the bottom up, and just in order to understand it, you need to do everything yourself, kind of like what I told you about the other product that I worked on with Actona, the way that I was part of the first few people that develop it from scratch. So when I started working on graphics, um, you know, I started taking up various features or bugs, and I always felt that I don't understand the entire pipeline. Just by fixing something here or there or doing some small feature. And even though I started reading some books on 3D graphics, I still didn't understand how everything works together. And so the way that uh, the, the way that it is working very well for me is to learn to do something and then to explain it to others. So that was the idea. So initially, that's what OpenGL was not my first step in graphics. I actually started with a book by Andre Lamotte called "Tricks of the 3D Graphics Programming Gurus," which is I just did a review of that book. If anyone is interested, you can find that on my channel. And the book explains how to build a full rasterization engine from scratch. And so that was my first attempt. And this is what really, um, this is how I learned to do graphics and understand, the pipeline and all the math involved. And I remember my first project was called Backward X, just a hobby project because it was, I was working on DirectX at the time, and I was not familiar with OpenGL, and so I said, okay, I'm going to develop DirectX myself, the same API with software, and I would call it Backward X. And I remember it was a lot of fun because what I did was I followed up on Andre's book, but the API matched what I knew from DX9 at the time. And I continue like that, and it really helped me understand stuff, like the Clipper and a lot of the elements in the pipeline. And eventually, I don't remember what happened before, whether because we stopped working on DirectX and we moved to OpenGL eventually. But I think I started. I mean, I don't remember what came first, but for some reason I decided to start learning OpenGL, and the idea was to learn and to explain to others at the same time, because when you do stuff yourself, just for yourself, and you get it working, it's cool and everything, but if you try to explain it to other people why it's working, you often find that you don't really understand it to the core. Okay, you were able to get it working, but you don't fully understand everything. And then when people start asking you questions, or when you work on a tutorial and try to explain everything, you start saying to yourself, oh, wow, I don't really understand everything here. I need to take a closer look, or do some more experimentations, or write this equation again and see exactly all the steps, just to make sure that when someone asks me a question, I'll be able to answer it. And that was the idea of the website, to explore and to understand 3D graphics by doing tutorials. So it was exactly like that. I wanted to understand how shadow mapping works. So I read the other tutorials, I made it work, and then I created my own tutorials using my own words, because the way that other people explain it is always different than how you see the problem and how you explain it. And once you explain it yourself to other people, you understand it in a different level. And that was the idea there. I started with a few tutorials, and it seemed to pick up very well. I mean, most of the comments and the feedback were very positive, and so I kept doing it for a few years. And eventually, due to various changes in life, I didn't have time to work on new material, so the website just sat there. And then about a year and a half or a bit more, kind of like, because I guess maybe because of COVID. I mean, one of the questions that I keep asking myself, or stuff that I tell myself, is why didn't I start doing YouTube earlier? I mean, if I've done YouTube, I mean, because YouTube was there at the end of 2010 when I started the website. YouTube was there. I even remember uploading one video for the skeletal animation tutorial, because this was something that was moving and everything. So I said, why don't I'll create just a small video to show how it's working and upload it to my channel. But I never continued past that. I was always focused on just writing stuff. And to tell you the truth, often with stuff like that, it's better to work with a written material, because a person talking on a video, sometimes you cannot understand everything at the same rate or speed that they are going, and you need to go back. And when you have the material in front of you, like a book or whatever, or an online tutorial, and just go back and forth on the text, sometimes it's more efficient. So I guess most people will work with various kinds of media, both written text and books and online tutorials and video tutorials, some kind of a combination. And I don't know why I got to YouTube so late, but that's how everything worked eventually. And so, and then I decided to start. Um, I mean, the idea was that I didn't work on graphics for several years, and by creating the channel, the YouTube channel, was kind of like getting back in shape in graphics again. And this is how I felt from one video to another. I also had to learn how to do YouTube, but I also learned graphics again, or just to refresh my memory on stuff that I already forgot.
Okay. And if, let's say, your YouTube stuff and let's say your website was generating enough income to, supplant your day job, would you take it up full time, or will it just remain as a part-time hobby?
Yeah, definitely. I mean, I can say this is kind of like my dream, um, because I've been working in the industry for many years, and I know how the way things work in the industry, the positive stuff, the negative. And this way of working on your own channel is very refreshing, I think. So if if I ever become more popular to the point where it can support my family, then this is definitely something that I would try to do. You never commit to anything for eternity, right? You can always, I mean, if you work on such a technical project like video tutorials on a specific subject, you become an expert on that. You can always say that, okay, I want to take a break from that, get back to a real company, and you can just jump back into the water. It's a no big thing. So it's not something that I tell myself I want to do it for the rest of my career, but if I'll be able to do that for at least a few years, then I think it will be great. A lot of challenges, in many respects, more difficult than to work on a regular company in a regular company.
Oh yeah, for
But
sure.
yeah.
Yeah, it's one of those things that anyone that's never done it and from the outside they just see it as, oh, easy. They just say, oh, you just sit in front of the computer, you create a video and you upload it. But as you know now, that there
Hmm.
are a lot of challenges. Challenges
Yeah.
from obviously thinking of topic ideas. Challenges of actually you mentioned it, just figuring out how stuff works. With YouTube, with recording, because I use OBS for recording, and just learning about that, and then learning some basic Photoshop skills for thumbnail creation and editing, and then some basic Premiere Pro skills, and all that other stuff that goes along with it. But then storing the videos and making sure you have backups of that, and sometimes that can cost extra money. And if there's any other problems that you have, and then when you're creating a video, I'm sure you've had this issue before, where you spend, let's say, 30, 40, maybe an hour or 2 hours planning a video. You go to record it, and then something goes wrong, and you have to redo the planning or redo the recording. Maybe the recording didn't successfully save, or maybe you get towards the end of the video and it's not working, especially with a coding project. You click run, and it's not working the same way that you made it work pre-recording, and you can't fix it in a couple of minutes, and you're at the point where you just know you have to redo it. Have you faced those problems?
Yeah, so everything that you said right now sounds familiar to me. I mean, yeah. I mean, if you're, I guess, if you're someone who is very interested in software development, but you find yourself, if you don't really love the whole YouTube part of editing and uploading and recording, whether it's on camera, on microphone, or working through all this YouTube process, if you don't really love doing that, then probably YouTube is not for you. But this is exactly the reason why I find this so interesting and refreshing, because usually software developers who work on regular companies, they have um, very similar sets of challenges, both from the technical perspective and also from the personal perspective of working with other people, dealing with conflicts, and making your voice heard and influencing the product or whatever. So these are kind of like the regular problems that people have in that domain. But then if you go to YouTube, you suddenly have a whole bunch of other challenges that are not sometimes not technical at all, or not entirely technical in the same sense of writing code. So, and I find it very interesting to understand and become an expert on. So this is one of the reasons why I'm doing it. Yeah. So yeah, I've had all these problems. I've from one video to the next, I'm sharpening up my process, and I think I'm pretty efficient in the way that I'm doing stuff today, but it's definitely not in the level that I hope to be able to do it in the future. And the only problem is time,
Hmm.
because right now I'm trying to upload a tutorial every 2 to 3 weeks. And when you have a full-time job, it's um, uh, it's amazing how if you make a mistake along the way, how how badly it can push your schedule.
Yeah,
Um,
and your
if
motivation
you
as well. It can
No, I don't
demotivate
think I
you
don't have
heavily.
a no.
You don't
No, I
have
don't
that.
have no. I don't have a problem with motivation. No, I think just finding the time in order to work on the videos. This is my biggest challenge, and also improving myself in terms of the tools. So getting a video out every 2 to 3 weeks, when you have a full-time job, obviously you cannot invest a lot of time on the graphics or the animation of the video, which is why I think my videos are very simple in terms of the slides and everything. I'm constantly looking out for stuff that other people are doing, and they are creating videos that are much more impressive in terms of the quality of the graphics and the tools. Some of the tools I'm just not familiar with. So, for example, a lot of people are doing animations using Adobe Illustrator, and I haven't found the time to just learn it. So it sounds silly, but that's just the way it is. And I'm using Caden Live to edit all my videos. In most part, I really like this software. I was able to get up to speed very quickly on that. I remember trying to switch to DaVinci Resolve at some point, and it was just, I remember just spending a couple of hours not being able to use the same process that I'm used to. And then I told myself, if I'm gonna wait until I'm fully proficient with Resolve, then it would take me a few more weeks to get a video out, and I was just not in the position to feel comfortable with that. I think because my channel is still very young, not so many subscribers. I want to keep creating more content constantly. So at least one video every 2 to 3 weeks would be great. Especially as initially, the first few tutorials I was able to do in 1 week, but then sometimes when I had to do, or when I wanted to do a tutorial for which on some algorithm for which I didn't have an example or didn't have my own working code for that, and I had to develop it from scratch, and it would take much more time. I mean, if you the way that I work today is that every video begins with a working sample. Okay, so I need to get something working in my own environment, and from there I continue to the script. Almost all my videos today are scripted. I found even the code review parts. I found out that it just works best for me, because the way that I work is sometimes I do 10 minutes here, 20 minutes there, so I can record one page at one opportunity that I find, and then another page, and then another half an hour later along the week to edit everything. So by using a script, it helps me, you know, just to create the script, review it a few times, and then just record it. It kind of creates a very nice pipeline that works well for me. I can never find a few hours, to just sit down and create, to record myself just talking about the code. I'm never able to do it at the level that I expect. So um, I create the sample, a working sample. I create the script. I record the script. I edit the script, only the audio, and then I produce the video by adding all the visual elements on that, and then it goes off to YouTube. So there are a lot of places where this pipeline can be improved with better tools, but right now I can barely keep up with the current speed. So hopefully in the future I'll be able to improve it. I don't know.
Okay. And how do you go about marketing and promoting your videos? Because obviously, you enjoy the video creation, you enjoy the code, but you want people to view it. So the more people that view it,
Mhm.
the better it is for the channel, better for you. And, I'm guessing you'll be happy by that. So how do you promote and market it?
So usually I announce all my videos on Reddit. There's a Reddit subreddit for OpenGL with about 20,000 people there. So whenever I announce a new video, I immediately I get a nice spike in new subscribers until it levels off. And also on Facebook, there are a couple of OpenGL related groups that I always announce the video there, as well as um, there's a very nice guy called Gendrik Ilner. Hopefully, I'm not butchering his name. He's doing the graphics programming weekly, if I remember. It's a newsletter, a weekly newsletter, and he is getting all sorts of resources, new resources that he finds or people send them, mostly articles about 3D graphics, often very advanced stuff that people are working on. And so he publishes his newsletter. So I usually send him also my videos, and he publishes them as well. He also has a large following on Twitter, so he announces it on Twitter, and then many new people are introduced to the channel. So the newsletter is a combination of both written materials and articles, as well as videos like me that other people are creating. And I mean, I have my own Twitter. Not that I think it's 200 people right now that are following it, so it's not that big a deal there. And also my own Facebook group or page, and that's mostly it. I mean, I don't think that there's a lot of where you can. And what else can I do?
Yeah, I know. Especially if you're not spending, money at it. That's the problem.
No, no,
And
no.
so, which one do you find, generates the most sort of views? Because I know personally, if you hit one or two of those Reddit groups, they definitely produce the most, spike in, viewers and clicks compared to stuff like Facebook. What's your experience? What produces, what do you say, the most results compared to the least one?
Yeah, so I think that Reddit, as well as the newsletter, are the ones that are bringing in the most subscribers. I think they have the largest following, so they would get the largest impact. But it's interesting that I still see people coming into the channel from my own website. So on you've got those YouTube analytics on the YouTube Studio, so they will
Mhm.
show you exactly how many people, how many views you've got from YouTube recommending your content to or from the subscription feed. People getting notified about a new video, and also how many people coming in what is called external access, and where exactly or how exactly is this external access partition from Reddit to Facebook or whatever. And then I still see a lot of people coming in from my own website. So I guess when people on Google search for OpenGL tutorials, they often find my website and as one of the top search results. And then when they go in, they will see the latest video, and then they often click on that, and then they reach the YouTube channel. So the fact that I have an external my own website helps me a lot, because you cannot really trust, or you cannot let YouTube do the work for you. I mean, unless your retention rate is so high that just YouTube pushes your video, and it sometimes happens to people, but for me it never happens. So I feel like I have to do the work myself. If I would just publish the video and expect organic views, then it would probably half the number of views and half the number of subscribers that I have. And it's not that I have a lot.
Okay. And so you're doing, actually, no, I'll save that question for in a second. So with the promotion side of things, do you is it a continuous process where you do it at launch and then you keep doing it for a video, or do you just mainly do it when that video launches and then you move on to the next video, promote it, next video, promote it, and you don't promote old videos anymore?
So I don't promote my old videos. I mean, promotion is kind of like a one-step thing. It's interesting because I found out that publishing a video has so much work, and not just work in terms of time that you need to spend on it, but also a lot of things that you need to do. So it's like a checklist of a ton of
Mm.
different things that you need to do. So I have a list in my Google Docs of the publishing checklist, and it keeps getting longer. I keep adding more stuff that I need to. For example, you need right now. I have early access to for the Patreon supporters. Okay, so they're getting 48 hours early access. So check. I need to make sure not to publish a video before they get their benefit, and from thumbnails to making sure that the time codes are there, that the subtitles are there, and also for the publishing. So it's and also to make sure that the latest code in GitHub is working, to put a tag on it, to back up the project, all the resource files that went into the project. I always back them, make a backup on a different drive, and so a lot of stuff that I need to do, and also publish on Reddit, publish um, on Facebook. Also, I forgot need to say a big thank you to Jeff from Kronos. There's a guy there named Jeff at Kronos. This is the organization which is responsible for um, creating and maintaining the OpenGL. It's a kind of a consortium of several companies. All the big companies are there, Intel included, NVIDIA and everyone. And they are publishing or creating the OpenGL specification, as well as Vulkan, as well as other OpenCL, OpenCV, all these open standards. They are publishing it. And there's a guy named Jeff who is doing their social media stuff, and he every video that I produce, I send him an email letting him know, and he publishes it on announces it on Twitter. And I also get a lot of access. I always see it's always interesting because he lets me know when the tweet came up and then came out, and then I look at the analytics, and after a few hours I can actually see the spike of the views going up as soon as more people were notified through Twitter, because OpenGL has, I don't know, 10,000 or more, 10K followers on Twitter. So it always brings in views. So this is another important source of or place of marketing for me. And so publishing the video, just to make sure that I've got everything in place, that I didn't forget anything like subtitles or whatever. Part of that is also the marketing. And then once I complete the checklist for the new video, then I just keep up with the comments and everything, try to get back to everyone as soon as possible, and then it's to continue to the next one.
Okay. And so you do a lot of graphics programming, which leans heavily towards gaming. Have you done
Mhm.
any direct game development and released any games? If not, would you in the future?
Okay, so I haven't done any actual game development, but I plan. I mean, it's can't say that I have an actual plan, but this is something on my wish list. So I have several books on game development. I'm really fond of learning stuff from books, because I think that books encapsulate good books, especially. Um, they encapsulate a lot of experience that other people have, and this is the one of the ways that you can get a head start by learning from other people, take advantage of their experience. And so I have some books on game development, and this is something that I would like to do, because I see that people who are interested in graphics development and game development, they are kind of like, they're trying to find their way around, and it depends on the amount of experience that the person has, because often they are not very proficient programmers, and so taking up on an API like whatever, OpenGL, DirectX, Vulkan, it's a major challenge. And also handling all the pipeline, the math, and creating an application. Sometimes they are not very experienced in C or C++, so they're trying to find a way, and they will start. I mean, people who are not focused on the game engines, because using a game engine is kind of like a different category. The game engine takes care of so much of the infrastructure that you need to bring up. So it's kind of like not something that, not the type of audience that I'm targeting right now. I'm targeting the people who want to write stuff from scratch, whether it's because they are interested in it, just from the technical perspective or the technical challenge, or they actually want for some reason to develop a game from scratch. And so once they've passed the first few stages of getting something, like a rotating cube or whatever, and that they want to continue to creating a game. So how would you do it, and how do you separate the game code from the part of the engine inside your game? You don't want them to be intertwined in a way that you can't use the same technology in the future. So this is something that I'm very interested in doing, not just in order to publish a game, but to understand how to do it, and to know how to explain it to others. I think this is very challenging and interesting for me.
Okay. And would you ever use an off-the-shelf game engine like Unreal, Codecast, Unity, Godot, or would you prefer just to create your own from scratch in OpenGL?
Yeah, I would love to do something on Unity, on Unreal myself. Just to, I think it's important to understand what's there, to understand what you can do with it, and if you're working from scratch, then what you need to develop in order to I wouldn't say match that, but how shall I put it? But the way that a game is created by a game engine. So if you want to develop something from scratch, you need to bring out the advantages of working from scratch, and then you need to understand the advantages and disadvantages of working with the game engine, and then it will help you focus on your from scratch experience. So yeah, again, it's just a matter of finding the time to do it. It's somewhere on the wish list, but there are so much stuff to do before that. So I don't know when I'll be able to. Maybe if I'll ever be able to work on it full time, then yeah, I'll be able to dedicate some time to understand game engines more.
Okay. So, side question. So, you live in Israel. There's a mandatory military service, as far as I'm aware. There. How was that experience for you when you did your mandatory military service, and how do you think that formed you as a person, especially doing development? Because that's obviously a fair bit different to that.
Yeah, so like most of high school graduates here, I joined the military when I was about 18, and it was not very interesting. I mean, I don't have a lot to tell there. I mean, I had a computer job there, and mostly about data crunching, specifically for human resources. That's what I did. So I don't have a lot of hero stories to share. So it's like 3 years of service, and then immediately I remember about 10 days after I finished my was discharged from the military. I started in the university. I entered the university and started learning, studying computer science. So this is very different from what most of the young people who are out of the army here. Many of them, they start by some soul searching. They want to explore the world and go do traveling. But for me, it was not. It was a no-brainer because I was interested in computers. I wanted to study computer science. So, and that just in terms of the opportunity, because the military service ended in March, and then there's the there are 2 semesters. There is the winter semester, and then the spring semester starts at that time. So I just started in the university and continued from there. And in terms of affecting a person, yeah, I mean, a military service, wherever you are, it helps you become more of an adult, and so you look at the world more seriously. We don't have stuff here like colleges in the United States, where very young people leave their houses for the very first time, and they have all the young environment around them. I mean, you're with young people in the military, but it's very different from college life, obviously. So people have to get their head straight very fast uh, in order to survive like that. And yeah, I mean, it affects people. Basically, makes them adults faster.
Okay. And
That's how I see it.
so obviously it's mandatory in Israel. If let's say there was a country where it was optional to do it for a few years in a similar fashion, not mandatory, would you recommend it, or would you say it's just not worth the time? Because just in our discussions, you do seem very, structured. You seem like, the YouTube stuff that you have like a list, you have a plan, of doing this, and that. Now, was that formed from the more rigid structure that you have in the military? And is that sort of in the culture in Israel in general? Because obviously the military, part of it is so influential.
Um, I think for me, it just came from experience in life in general, and specifically in my career. That it helps me when I do stuff structurally, then it helps me actually get something done. And I don't know how much of the military affected that. It's difficult to say. I think it's just the years of experience of working with several companies, many people, different teams, different projects. It boils down to that. And would I recommend? I mean, in the United States, military service is voluntary, and I guess people who are drawn to it simply find it, I don't know, fits their character, because it's especially at the early stages of service, when you just start your training. It's not like at home, but people often find the challenges in that attractive. So I think it's too personal for me to either recommend it or not recommend it to anybody. I don't know. That's a very large question, because um, it affect it. It's also very dangerous depending on what you're doing, because if you're in many cases, it may not be dangerous if you're like in some technical position, in some base or whatever, and you don't really, it's not like out there in the field. It's not that dangerous, but it's still very compulsory, in the sense of, you're a soldier, you have to obey all orders and everything. Not many people like that, but other people find that very adds a lot of meaning to their life. So, and they are attracted to that. So depends on what exactly you're going to do. I can't recommend. um, I'm not the type of person that can recommend like going to something like the Navy SEALs. Yeah, you need to take a SEAL in order to explain to you what he found, or he or she found in attractive in that kind of service, and explain, because there are a lot of dangers involved. So this is not the kind of service that I can recommend or not recommend. You need to take someone from inside that.
Okay.
Hopefully
Uh,
that made sense. Made
yeah,
some
no, no,
sense.
no. It makes total sense. Obviously, so it's all relative. So with COVID and everything, a lot more stuff has become remote. How much of your job is remote, and what's your opinion of remote working versus being in the office? And how did you find the whole COVID experience, and what was it like over in Israel compared to, let's say, something in the West where there was like crazy lockdowns?
Yeah, so we had our share of crazy lockdowns here initially. And for a very long period of time, all the work, I mean, since March 2020, we've been working mostly remotely. And then in the past few months, um, it became more flexible. I think that right now, basically, we can work the entire week there. So 5 days a week, we can work at the office. And I myself, some of the people have actually in the team gone back to fully being on site. Um, I try to get there about twice a week. Some people do it 3 times a week. So, for example, from Monday to through Wednesday. And so for me, I try to do some kind of a hybrid. So 2 days now, maybe three later on. They are very flexible, allowing us to choose how we want to work. Other people simply prefer to work remotely exclusively, and they do that. And in some ways, it was very challenging because, especially initially, when there were lockdowns and there were no schools, and so the kids were home. So working with a couple of young kids here was very challenging. There's a lot of noise and everything. And in other ways, it's very easy because you're at home, and from a nutritional perspective, it's always better. Food at home is always better than everything that you can get outside. That's the way I see it. I mean, it's always definitely more cleaner and more healthy. And uh, also, I like my wife's cooking, so for me, it's a win-win. Always prefer to eat at home. And no, there are no. You don't need to commute. It's not like I have a large commute today. It's like 20 minutes to get to the office, but it's still when getting to the car and driving and parking and everything. It's like you can save almost an hour every day from all the entire process of commute. So, but then you need to make with commute. There is the advantage of kind of like a buffer zone before after you finish work and before you get home. There's a buffer zone where you can drive and listen to a podcast or whatever. And now you kind of like need to decide, okay, I'm going to stop now or I'm going to work for another half an hour, and the kids are already back and there's noise going on in the house. I need to decide, okay, so this is a good place to spot, and then you immediately switch to your other life. And sometimes it takes time to sink in.
That's fair enough. I think
So
that's okay. And I mean, yeah, we've been going for almost 2 hours now, so I think we'll wrap up here. I've got a list of more questions that I want to ask, but this podcast's already gone for 2 hours, and that's a good
mhm.
length for the audience. And we'll definitely have you back on again to go through the other questions. So one last question before we wrap up: what advice would you give as a developer to someone else that's starting out and that maybe wants to work for a big company? Because I know my wife, she like her dream job is to work at Cisco. And so like what advice, not just her, but just in general, would you give to someone as a developer?
Yeah, so I think that the way that I judge code is that how fast can other people can get up to speed on that and make changes in it. And sometimes other people is often future you. If you look at your code from 3 months, 6 months, a year in the future, how would you? What would you say about it? Did you do good job in terms of making it structured and well documented, not just comments, but self-documenting in the structure and the design so that you can make changes? And often I find that striving for simplicity is very important. So don't just go blindfolded after new technologies. Yeah, for example, I had a piece of code that someone else written using C++ variadic templates in order to implement something in very little amount of code. And that's okay, but the code itself was so difficult to read. It's not a lot of pieces, it's just a few lines. But I would just prefer in that case to use standard C++ without those templates. And even if it causes a bit of code duplication, don't go out of your wits just to avoid any code duplication. Sometimes duplicating a small piece of code and getting rid of all the hooplas that you had to do in order to remove to drop a code duplication is better. So I think that simplicity is a very important thing in programming. And I think that when you work with people. Okay, so another thing is don't get attached to your code. Okay, so if you remember the movie Hit in the mid '90s with Al Pacino and Robert De Niro, he told him if you want to get if you want to get, I don't remember the exact wording, but if you want to work as on the street doing what he did as a felon, then have nothing in your life that you can't leave out on in 30 seconds. Okay, because that was his life. He was like, there may be as soon as you feel the heat around the corner, you need to drop everything and just leave. So you cannot have like a normal life. So in the case of code, don't get attached to the code that you've written. Always be able to drop everything and do something else. Don't get attached to your code just because you've written it. Always be ready to rewrite it or whatever. Or if someone tells you something, don't get offended because it can be done better. Just if you think about what they said, if you got a good advice, then just do it. People often get very protective about what they've written, and they don't want to change it, or they get offended because someone criticized their work. And sometimes the criticism is not delivered in a way which is very constructive or positive, but still, you need to look at the technical merits of what you were told, and just take the advice and do what's best for the project. I think it's very important. Just from the top of my head, a couple of advice.
Some good advice. Yeah, definitely for sure. You don't be too married to, your way of doing things, your code, it could be your development, setup or whatever it is, be open to change. And I think that's a pretty
Yeah.
good, piece of advice in general for life. But I definitely I know several developers that I mean, they're good, and that does not help, the fact that they're good. And as a result, they don't want to change because they know that they are actually good. Because if they weren't that good, I feel like they probably would be more likely to maybe change. But because they get their job done, it works well usually. They know a fair bit. They feel like they can't learn anymore. So yeah, there is that problem with developers. But it's good advice in general for people. And so yes, I want to thank you, Etay, for jumping on the podcast today. Really appreciate it. I think everybody will, have learnt a lot, especially if they're, looking to learn more about the ins and outs of startups, companies. I know I've learnt a lot just from, listening to you for the last, couple of hours, and really appreciate it. Would like to have you back on again soon, and I'll put all the links for Etay's work. So, the website, YouTube, the subreddit, Twitter, all that stuff. I'll get all those links off you, afterwards, and I'll make sure that's in the description so you guys can check that out. So thank you, Etay. Thank you, everyone, for listening. And if you like the podcast, just give it a 5-star rating on whatever platform you're on. And yeah, thank you.
Sure. Well, thanks for having me. Bye-bye.